Hello everybody. So today we are going to start a new concept that is integration by partial fractions. So first we will see when we are applying this partial fraction concept in the integration. So as we know that in the derivative for the product of the two functions we have one rule set of rule to differentiate that things, right? Similarly in the integrations also when we have the two functions are in the product then how we have to integrate it, we have a set of rules, and that is only called as the integration by parts. That is by parts, right? That let us suppose here we have given integration of two functions are multiplied. One is u, another one is v, and we are differentiating, sorry, integrating with respect to x. So what is the rule? Here we need to first decide the first and second functions. We need to decide first and second function. How we are deciding this first and second function, that also we'll see. First here we are assuming, let us suppose this is our first functions. There is a rule to decide also. So that will come on after this. So this is, let us suppose, first function and this v is the second function. Right. So always we are writing the u here and then integration of the second functions we are taking. So second is v. So v into dx and then minus sign into integration. Here inside integrations we are taking the derivative of first functions. That means d dx. Since we our function is here x, we are differentiating or integrating with respect to x. So d dx of what? First function. That is u and then integration of the second function. So it is v into dx, right? Bracket close. And since there are two integration sign, this one and this one, so we have to take the one more dx, right? So this is the rule for integration by parts. By parts, there is just a simple rule: integration by parts. What is that? If you have integration of u v into dx, so we need to decide the first and second functions, and then first function will be outside, and then we have to take the integration of the second functions into dx minus integration of derivative of the first functions integration and then integration of the second function dx, right? Now how we are deciding the first and second function? How we are deciding the first and second function? So that is based on the Eilert rule. This is Eilert rule. Let us suppose here I am writing ILAT. So Eilert rule, here you have to understand what is Eilert. I stand for inverse functions. That stand for inverse functions. Inverse functions like what? If you have sine inverse of x, cos inverse of x, x to the power minus 4. So these type of the functions are called as the inverse functions, right? L stands for the logarithmic functions, log x, log y, or anything related to log, right? So logarithmic functions, logarithm function, right? Now next one, A. A is the algebraic functions. What is algebraic functions? Here any equation in terms of x, y is here. So algebraic functions, right? Means product of the variable and constant. So algebraic, sorry, here spelling we have to correct it. Algebraic spelling is algebraic functions, right? Next we have T. T again simple. T means trigonometric functions. Trigonometric functions. Sine, cos will be involved, right? So trigonometric functions. That is, we are saying trigonometric functions. Now E. What is E? So E stand for exponential functions. E stand for exponential functions. E stand for exponential functions, right? So now we'll take some example to understand it more clearly. So let us suppose here we have given the first question I'm taking, first example. So integrate, you have to integrate, let us suppose log x. How we can integrate it? We don't have any direct formula for integration of this log x. That means here again we have to apply the partial fractions concept only. But problem is what here we have given only one function. How we can apply the partial fractions? Because we know that partial fractions is applicable only when we have two functions or product of the two functions. Then only we can apply it, right? So yes, if there is no only one function, we can add one more function. Means here we can rewrite it as log x and 1 we can multiply. Now this 1 is our exponential, sorry, algebraic function. So we are multiplying with this because anything multiplied with 1 will be same only, right? So now here we have the two functions and according to the islet rule, islet here what is our rule? Islet. So according to the Euler rule, we know that log is the second function and algebraic expressions is the third function. That means this is coming first. L is coming first than the algebraic functions. So logarithmic function, this is our first function and 1 is algebraic functions. So 1 will be considered as the second functions. Right? Now we can apply the formula here. So according to the formula, here first function will be outside, that means log x will be outside of the integrations and we are going to integrate the second function, that means 1 into dx, right? And then minus integration and here black bracket and derivative of the first function, that means dx of what? So dx of log x, dx of log x, and then bracket close integration of again second function. So that is not bracket close. Here we are not closing the bracket. Bracket will close after this integration. So here integration of second functions, that is 1 into dx, and then now bracket close into dx. This is the rule. So now here log x is as it is, but we have to write the integration of 1. So integration of 1 is x, right? Minus integration derivative of log x, we know that it is 1 by x. Derivative of log x is 1 by x and derivative of again x is x only. That means it become x into dx. That means here you can see very clearly this x and x will get cancelled out. Both x will get cancelled out. That means now we have here x I am writing first, means it is x, and then log x, just I am rearranging the terms, and here we have minus integration of what? So 1 into dx, and as you know that integration of 1 is again x, that means here we will get x into log x minus x and at last plus c. So this is our final answer of the question number, this example, right? Now let's take another example. So another example I am writing. Suppose you have given integrate x into e to the power x. How we can do that? Again, we have to decide the first function and second function by the rule of islet. Islet. So islet, that means x is algebraic functions. This is our algebraic functions. It is in the third place, and exponential function is at last, right? That means here first algebraic functions is coming. So here this is our first function, and e to the power this is the second function. So how we can differentiate, integrate it? First function will be outside, means here first function, that is x outside, and we will write integration of the second functions into dx. All right. Then minus here, minus integration of derivative of the first functions. That means d dx. Derivative, that means d dx of what? X. And then integration of the second functions, that is e to the power x into dx. Now bracket close and here dx. Right? So now what we can do here? This x into e to the power x minus integration x derivative is 1 and e to the power integration is e to the power x, and this dx will be as it is. That means from here x e to the power x as it is, and just once again e to the power x e to the power x, and here e to the power x integration is e to the power x. So plus c. This is the answer. So whenever we have given this type of the questions, then also we can apply the partial fractions. Now I am taking the another question, that is trigonometric terms we will take this time, inverse trigonometry. So let us suppose we have given I is equal to integration of x into sine inverse x. Sine inverse x into dx, and this is divided by under root of 1 minus x square. Under root of 1 minus x square. So how we can solve these questions? Again, first, you can see here very clearly, we can see if you know the formula, the derivative of sine inverse x is present in the denominator. So substitute here or apply substitutions and reduce the terms here. That means if we are saying this sine inverse x is equal to t, so what will be the differentiation of this? Differentiation of sine inverse x, as we know that it is 1 upon 1 minus under root of 1 minus x square, and here dx, and this is equal to dt, right? That means what we can say here, I become now I is equal to x equal to, from here x equal to what we can say, x is nothing but sine t, or not? Yes. Since sine inverse x is t, so x equal to sine t. Now we are going to replace x with here sine t. And this sine inverse x is equal to what? Sine inverse x is equal to t. And here we have 1 by under root of x square into dx, means this term we are going to replace this complete with this. This is with what? dt, because here we have already we have written in this form. Sorry, this. That means this will become dt. Now again you can see here we have the two terms sin t and t, and according to the Euler rule we know sin t is in the second last, and t means algebraic equation. That means it is the before t, means t is the first function and sine is the second function here. So we are going to apply the formula sine and t we have, right? So t will be first functions, means just once again here we will write integration I is equal to t outside and integration of sine t with respect to dt, right? Minus integration derivative of the first functions. What is the derivative? So d dt by t, and integration of the second functions, that is sine t, right? And then here dt, bracket close, and then multiply with again dt. Now what we can do, t as it is, differentiation of the sign we know that is minus cos t, is minus cos t, right? Minus integration of derivative of the t is 1, right? And sine t integration is minus cos t. So it is minus cos t into dt, right? So from here it is minus t cos t. Here this is done, or means this first part derivative integration is done. Now we have to think about this. This minus will come outside, and this minus minus will become plus. So we have just integration of cos t into dt. That means now we can write our answer here. It is minus t cos t, and the integration of the cos is sine. So it is sine t. And then at last we are writing plus c. But we need to replace our t. What is the t? As you can see in the previous slide, we have considered t is equal to sine inverse of x. So if here we have the cos and sine, in the questions you can see here we have cos t and sine t. So here sine t equal to, we have, you can see from this slide here only, sin t is equal to x. So from here, can you tell me the cos t values? So this implies from the first identity sin square x plus cos square x, we can say that from here this cos t will be equal to under root of 1 minus x square, right? 1 minus x square. So we are going to replace here, means this will become finally minus t means what? Minus t means cos inverse of, sorry, sine inverse of x. It is sine inverse x, but cos t is under root of 1 minus x square. 1 minus x square, and here plus sine t means x, and plus c. So this is the plus c actually here. So I values means final integration answer is this, right? So this is also simple, right? Now here next one more questions we'll do, that is exponential functions. Each type of the questions we will do at least one. So here next is the third questions. This will be the third. This was a second. So now third one. Here I am writing. Third is we have given, let us suppose, integration of what? So integrate e to the power. If it is e to the power x and sin x, how we can do that? Into sin x into dx. Here. So again, Eilert rule. What is Eilert rule? It is deciding the first and second functions, right? So exponential function, as you can see, it is always in the last. That means before that sine is coming. So sine is our first function, and I means it is the second function, right? All right. That means now here we can say I is equal to first functions we are taking first outside means sine x will be here, and integration of e to the power x into dx, all right, minus integration of derivative of the first function d dx of sin x, d dx of sin x, and then integration of the second function, so that is e to the power x into dx, and then here dx, all right. So now it is sin x and ex, integration is ex. Here derivative of sine is, we know that is cos x, and cos x and integration of the e to the power x is e to the power x, and here dx. So now you can see very clearly, again we are getting the product of here cos and E means trigonometry into exponential functions, this one. So now we have to solve this part actually, right? So I'm putting in the bracket because before that minus sign is there, right? So I'm going to solve that part again. Means here I will be equal to what? This first term as it is, we are writing this sign x e to the power x as it is. But inside this bracket, what is our first function? So here, according to the Euler rule, this is first and this is second function. That means first is first is cos. So cos will be outside, and integration of e to the power x into dx, minus here we are going to take integration again, but derivative of cos x means d dx of cos x, d dx of cos x, and then integration of what? Integration of e to the power x into dx, and here this bracket close, and there is already here also one bracket close. So better keep the curly bracket so that will not have confusion. Right now, it is I is equal to what we are getting? I is equal to sine x, and here into e to the power x, minus here this is cos x e to the power x, integration e to the power x. Here inside integration it is cos will become minus sign, so minus and minus it will become plus, means here we have now minus sine x, and integration of e to the power x is e to the power x, and here dx. Now if you observe the given thing in the given question also, in a starting we had given here what? This is I only, e to the power x into sin x dx. This is I, and here also we are getting the same thing. So what we can say here, this is nothing but I can be written as, here in place of this we can write I, right, and open the bracket also. So this will become finally I is equal to sin x e to the power x, and here if you open this bracket, so it will become minus cos x e to the power x, and this minus plus will also become minus, and this here this red underlined part I am going to replace with the I, because this is exactly given data only. So this minus I and this, if you take this minus I LHS side left side, so it will become I plus I, it will become 2I, right? So 2I is equal to, we have here e to the power x I am writing first, and sine x, right, minus cos x, and here also we have e to the power x. We can take e to the power x common also, right? So now we are going to take these two in division and e to the power x common also. So e to the power x divided by 2, and if you are taking common here, you will get sine x minus cos x. So no confusion, right? And plus c here we will write. So this is the final answer of these questions. Right? Now we have one more type of the questions, and for that we have to remember directly the concept or formula. So I will explain first the concept. Let us suppose here we have given this type of the function. Just one second. Here we have given the we can say different. This is one of the concept only. We have to integrate. Let us suppose e to the power x, inside bracket we have given f of x, and then here only we have given derivative of this f of x, that means f dash of x into dx. So answer for this type of the questions is directly we can write answer will be e to the power x into f into x, right? And then plus c also we can write. But how we are getting this? So we'll see their proof here, and then we'll apply directly from now onward in this type of the question. So here you can see the proof. Just we have to, for the proof, expand it. Means this, if we are considering this is equal to I, so this I, how we can write? I is equal to e to the power x is there. We will open this bracket. So integration e to the power x. Here we will get f x and then dx. Right? Here we will get plus integration of e to the power x, and here f dash of x, right, into dx. All right. Now what we can do? Here we have to integrate this part. We have to integrate this part. What is the integration of this part? Because it is given in the derivative, and we know that derivative is opposite of the integration, right? So when we are going to apply the integration on this, so what we are getting here, we will just, this part we will not disturb. Let this part be as it is. Let this part be as it is. We are going to integrate this part. So here we have the two functions, so exponential functions and algebraic functions. So here we are considering this is our first function and this is the second functions, right? So it will become I is equal to what? Here we can say I is equal to integration of e to the power x fx into dx, fx into dx. And here first function is f dash of x, so I'm writing f dash of x, and then f dash of x I'm writing, and then here mm, it will become integration of the second function, so that means e to the power x. All right, e to the power x, or f dash of x we want to cancel. So how this f dash of x will come? So let's see. So here I think we need to take the integration of this part. What we have to do, I1. So instead of this, if we are taking, let us suppose this first part integration, instead of this, already it is given in the f dash. So here, instead of this part, we are going to consider the first part. Means this we are going to integrate, and this part will be as it is, no changes, as it is. Here you consider this as the first function and this as the second function. So I will become what? I will be equal to e to the power, sorry, f x outside of the integration, and we have to integrate e to the power x into dx, and then minus sign here, integration inside derivative of f dash of f of x, that means it will become f dash of x, and integration of e to the power x into dx. And in bracket we have to write in bracket, and again we have to give one dx, right? And the second part is as it is. We are not doing anything with this. This we will copy as it is. That means this is e to the power x f dash of x into dx. All right. So now here simplify this. It will become f of x, and from here e to the power x, because e to the power x integration we know that is e to the power x only, and minus here integration of f dash of x as it is, and here e to the power x integration is e to the power x into dx, and we have here integration of e to the power x and f dash of x. Now you can see here why we were not taking the integration of this part, because from the first part we are getting the same thing but in opposite sign, so it will get cancelled out here, means this part and this part will get cancelled out. So we have remaining what? We have remaining this I is equal to f dash of x into e to the power x plus c. That's why we are writing our answer directly in this form. Whenever we have integration in this form, we are writing e to the power x into fx. So this is the proof. Now we'll do this some questions based on that. Let us suppose here we have given e to the power x. Question number will be 4, no? Yeah, it will be 4 only. So the question number 4, let us suppose we have given I is equal to integrate e to the power x, in bracket we have tan inverse x, and plus 1 by 1 plus x square and into dx is there. How we can apply this thing? So what we need actually to apply this concept? So here, if this is, let us suppose f of x, so their differentiations would be present in the second term, right? So let I am considering this tan x is equal to tan x is equal to f of x. Sorry, tan inverse x is equal to f of x. So what is the f dash of x? If you are taking the differentiation of f dash of x, this will become 1 by 1 plus x square. All right. That means this is given first and this is given the second. That means yes, it is in the form of what? Since we know that whenever we have integration in the form of e to the power x into f of x, and the differentiation of this f of x is present here, that means f dash of x into dx, then direct our answer will be e to the power x into f x and plus c. So according to this formula, here our answer will be equal to what? I will be equal to e to the power x, but this time here f of x is tan inverse x. It is tan inverse x, and here plus c. So this is the answer. Right? So here this is the answer. One more questions will do. That is the last question for this concept. So what is that? Fifth one. Fifth one we have given I is equal to integrate what? Integrate x square plus 1 and e to the power x dx. And this is divided by x plus 1 whole square, right? So how we can do here? Also we will try to apply that formula. So how we can think that that is applicable or not? So e to the power x is there. Whenever e to the power x is given, we need to think in that way, that whether that formula is applicable or not. So x to the power 1 and here divided by x plus 1 whole square is there, right? Whole square into dx. That means, can you convert this bracket part in the terms of fx plus f dash of x, because it is not directly given in that form? So yes, we can do. Means here we have given x plus 1 in numerator also. If we can get x plus 1, so it will get cancelled out. For that we are going to do some substitutions. Means here we can rewrite it as e to the power x. Here I am going to subtract and add something. Means here I am going to subtract x minus 1, and there is plus 1 already, and plus 1 I am adding also. So like this we can add and subtract, there is no problem, because overall it will get cancelled out and value will be same. So and then here we have now dx. All right, now what we can do here, this e to the power x is it as it is. Now we are going to take this divided by this x square minus 1 divided by x plus 1. So here this will become x square minus 1 and this is divided by x plus 1, right? Whole square. And the second term 1 plus 1, this 1 plus 1 it is 2. So 2 divided by x plus 1 whole square. All right. Now we have, you can see two terms, but here we can cancel e to the power x. If you see here, 1 we can write as 1 square. So it will be x minus 1 into x plus 1. That means here remaining will be x minus 1, and with x plus 1 denominator power will get cancelled out. So here we have just x plus 1, and here we have 2 by x plus 1 whole square, right? Into dx. All right. So if you observe it, this is nothing but the f of x. This is f of x, and their differentiation is this. So you can take the differentiation here. You will get the same thing. Means if you are taking, let this f of x equal to this x minus 1 divided by x plus 1. So this f dash of, if you apply the division rule here, quotient rule, so you will get denominator whole square, because u by v rule we are applying, and here you will get 2 only, because x plus 1 differentiation will be 1 and x minus 1 differentiation also will be 1. So 1 plus 1 will be 2. So here we are getting 2. That means this is what we are getting as f dash of x. So now next thing is what? We can write our final answer, means we can say I is equal to e to the power x into f of x. So f of x here is x minus 1 by x plus 1, right? And then plus c. So this is the final answer. And this is only the concept we are using in the NCRT. We can solve all the type of the NCRT question if you understand this concept. Thank you.